I'm Allison Klein from Tech Arena, and we are at OCP Dublin. I am so excited to be with Nilesh Shah from ZeroPoint Technologies and an insider in OCP. Nilesh, thanks for joining us today.
Thanks for having me, Allison and Team Tech Arena.
So, Nilesh, there has been a topic that has been inserted into the OCP Summit this week, and it was brought by you. It's NeoCloud. You led a discussion on it yesterday. Tell me about what NeoCloud is and why it's important to the discussion around open compute.
NeoCloud is a relatively new term. It's a way to differentiate the data centers built around AI and AI-first data centers. So these are the data centers built exclusively for GPU accelerated computing, and they have significantly different needs from your traditional data centers, which are built to fail. Actually, a lot of the traditional data centers workloads have multiple CPUs. They're built around CPUs, and AI data centers are built around GPUs and other custom accelerators. So they have very different power requirements, kilowatts per rack, 30 to 50 kilowatts per rack, whereas the traditional data centers, the racks are maybe like a kilowatt, couple kilowatts per rack. So there's a very different need, and NeoCloud's OCP is focused on hyperscale end consumers like Meta and Google and Microsoft. And we have this new wave of NeoCloud companies popping up all over the place, like CoreWeave, and we've heard so many like Lambda Labs, and there's a bunch of them. And all of these are actually focused on delivering generative AI first. So that's the big difference, and that's why the need to cover some of their use cases and the end customer use cases they are bringing in.
You know, I see this as a really important point for OCP evolution, is to figure out how we bring NeoCloud into the open computing community. One of the topics that came up in this discussion that I wanted to drill into with you a little bit is the need for new memory and storage innovation. Why is this so critical for NeoCloud?
Yeah, I'll start off with a real example. So if you look at the large language models, if you break them down, if you look at, typically these large language models have multiple layers, like hundreds or even thousands of layers. And they typically have a pre-fill stage and they have a decode stage. And if you look at all the decode stage, which are later on in the layers, and when you're trying to run inference, so I have a model, I've already trained it, now I want to get some value out of it. The performance of those models is all memory bound, not compute bound. So our traditional view is, oh, I'll just throw more compute at it. But that's not actually going to improve your performance. That's driving the need for innovations in memory technology. So the couple of things that we spoke about were, one is compression, memory compression, so real-time hardware accelerated compression, so you can get more capacity, more bandwidth for the same amount of memory. And the other thing we were discussing is emerging technologies like MRAM, which are actually now very friendly towards the use cases of LLM inference, because they're more read intensive, like a ratio of 6 to 1 reads to writes.
Well, Nilesh, thank you so much for being on the show today. It was great.
Thanks, Allison. Thank you for having me.